Well, today we're going to start looking at something that's called a logarithm, and it is an extension of what we learned with exponential functions. So that's where we're going to start. We're going to start with already what we know, which is the graph of an exponential function. So when we graph y equals 3 to the power x, it is not difficult for us. We know that if we put x as being 0, anything to the power of 0 is 1. So that point is going to be on the dot, 0 and 1. If x is 1, we get an answer of 3. So the point 1 and 3 is on the graph. And we could continue on to 2 and 9, because 3 squared is 9, which gets us right there. So we have the point, if x is 2, y is 9. Similarly, if we go to negative exponents, we get 1/3. And I will just stop there with that being the last point we draw. And we can see that our exponential graph is an increasing graph that looks like so. And we have an asymptote at y equaling 0. A logarithm is the inverse of the exponential function. What is an inverse? To find the inverse of a function, we switch x and y. So in terms of the equation, if we switch x and y around, we get this value. In terms of our points, the x and y values will also switch, as will our asymptote. So our asymptote on 3 to the power of x is y equals 0. Our new asymptote is x equaling 0, which is the vertical line x equaling 0. Then all of our points switch. So 0 and 1 becomes 1, 0, which is right there. 1 and 3 becomes 3 and 1, which is right there. 3 and 1. 2 and 9 becomes 9 and 2. And negative 1 and 1/3 becomes 1/3 and minus 1, which would be about there. And when we connect those, we get this shape, which is the inverse shape to the exponential function, and that is called a logarithmic function. And if we want to write it as a logarithm, we would write it as such, which is more the focus of the next lesson. Now, we're going to start with this. Another question very similar would be if you took a function that would be decreasing, which would look like so. What would the inverse of that look like? Well, again, it ends up with a new asymptote there, and the shapes just switch. So if we think of the key points again, we would carefully graph it, and we would draw the inverse of it, and so we would end up with a shape that looks like so. And we're going to talk about that more next class. We'll also talk about what the significance of these log-looking expressions and how do we deal with those. But that's a real basic introduction to 8.3, and we'll go over the details when we get to class. That's it for now. I will see you soon.